The head coach of the football team believes that Jones should be the starting quarterback for the game this week. 8 of the other coaches agree with the head coach, but the remaining 7 prefer other choices. A committee of 5 of the 15 coaches is formed to make a recommendation. What is the probability that of 5 of the 15 coaches selected at random for the committee to make the decision, at least 4 members of the committee will agree with the head coach? We approach this problem first by defining the random variable. What are we interested in? Answer: number of coaches that agree with the head coach. We will call this random variable X. Number of coaches that agree with the head coach. What type of random variable is it? Only 2 choices here, continuous and discrete. Answer: discrete, because the random variable is measured in whole numbers. Next, what values can the random variable take on? Meaning, what are the possible values of X? Answer: 0, 1, 2, 3, or 4, or 5, okay? Because there's only 5 members of the committee. Finally, what values of the random variable are we interested in finding the probability for? Answer here is actually 2 values. The probability that X is equal to 4 or X is equal to 5. And this is because we asked the question at least 4, which of course includes 5. Now we have to count. First, how many unique ways can we select 4 members from the group of coaches who agree with the head coach? Here, the combinatorial formula provides us with the answer. 8 combinatorial 4 is the total number of unique ways that we can select 4 from the people who agree. Okay? Now, we have one more slot to fill because we're going to have 5 in our committee, and those have to come from the 7 who disagree with the coach. And that's going to be combinatorial 7 combinatorial 1. We only have one more step to go, and that is how many total possible 5-member committees can you create from 15 unique elements? And the answer there is 15 combinatorial 5. Okay? This is the total number of unique ways to create a committee of size 5 from 15 possible members. By just using counting formulas, we have now created something that is called a probability density function. This one is called the hypergeometric probability density function. Probability density functions are mathematical formulas that describe exactly the probability of certain experiments. We can use these formulas to calculate probabilities if the experiment follows the mathematical requirements of the probability density function. These things are truly amazing, as we discussed earlier. Probability density functions, however, are only useful for specific experiments. In this case of selecting a committee of coaches, the experiment tells us that the hypergeometric probability density function is appropriate. The rules are: the population must be divisible into 2 and only 2 independent subsets, coaches who agree and those who do not in this example. The experiment must have changing probabilities of success with each trial. The fact that the names selected to be on the committee cannot be selected twice in this example makes this true here. This is basically saying we draw without replacement. The last, the random variable must be discrete rather than continuous. Now to the solution. We have one more step. The question is, what is the probability that the committee has 4 or more coaches who agree? Now we are interested in not only the probability of having exactly 4 people, which we have already here, but also the probability of having 5 on the committee who agree. We will have to solve the problem twice, one for each number, and then add the 2 probabilities together. We know this because the addition rule reminds us that the word or translates into addition in terms of the addition rule. The general formula for the hypergeometric distribution is as follows. The probability of X is equal to A combinatorial X n minus a combinatorial to n minus x divided by capital N combinatorial small n, where capital N is the total number of items we're drawing from, in this case the coaches. Okay? A is the number of those that we're interested in. These are coaches who agree. And x is the number that we're interested in for finding the probability. To finally solve the problem, we simply add on, this is going to be 8 coaches who agree, but this time we want 5, combinatorial 5. There are 7 who disagree, and we want none because all 5 of them are agreeing, and we divide that by 15 combinatorial 5. Okay? When we want to solve that, we can work it out, and the answer is going to be 0.1818. Ta-da!